A nuclear submarine does not run on fuel in any conventional sense. Its reactor core contains enough enriched uranium to power the vessel for decades without refueling. It generates its own electricity and its own fresh water through onboard distillation systems. And it produces its own breathable air through the electrolysis of seawater. It can travel at sustained speeds exceeding 25 knots submerged and dive to depths beyond 300 meters. By every technical measure, a nuclear submarine should be able to stay underwater indefinitely. And yet, every nuclear submarine in service returns to port on a schedule. This happens not because the technology requires it, but because the crew does. The one resource a nuclear submarine cannot generate or recycle indefinitely is human endurance. Keeping 130 people functional in a sealed steel cylinder for 90 days requires engineering decisions as vital as the propulsion system. The pressure hull of a Virginia-class submarine is about 115 meters long and 10 meters in diameter. The habitable volume is far smaller than the hull dimensions suggest, occupied by machinery and weapon systems. Crew berthing is arranged in 3 high bunk stacks in spaces so confined that a member cannot sit upright. Hot bunking is standard practice, where 2 crew members share the same bunk on alternating watch schedules. The atmosphere management system is the most critical life support system on the vessel. Oxygen is consumed by a crew of 135 at a rate of approximately 113 kilograms daily. The primary oxygen source is electrolysis, using electrical power from the reactor to decompose water. The hydrogen byproduct is vented overboard through the hull, a process requiring careful management. Hydrogen is explosive above 4% in air, making its safe removal vital to survival. Carbon dioxide removal is equally critical, as the crew exhales about 200 grams of CO2 per person per hour. Monoethanolamine scrubbers continuously absorb CO2 from the atmosphere to keep it breathable. Lithium hydroxide canisters provide backup CO2 absorption when the primary system needs maintenance. Trace contaminants off-gassed by machinery and humans accumulate without dilution in a sealed environment. Carbon monoxide from cooking and freon from refrigeration systems can build up over time. Catalytic burners oxidize carbon monoxide and hydrogen, while activated carbon filters remove organic compounds. Acceptable limits are set conservatively, as the crew will spend 90 days breathing this air. Chronic, low-level exposure can become a serious health concern over such a long timescale. Fresh water is produced by distilling seawater using heat from the reactor's secondary cooling loop. A Virginia-class submarine can produce approximately 7,500 liters of fresh water per day, sufficient for drinking, cooking, and limited washing. Water rationing is nonetheless standard practice. Showers are typically limited to 2 minutes every few days. Laundry is managed on a rotation. The water system must also supply the electrolysis units producing oxygen and maintain cooling water for electronics and the reactor systems. The competing demands on the freshwater system are managed through strict allocation protocols. Food is the hard constraint that most directly limits patrol duration. A submarine carries a finite supply of provisions loaded before departure. A 90-day patrol requires approximately 35,000 to 40,000 individual meals. Tons of food are stored in every available space throughout the boat. Early in a patrol, food is stored in passageways and the torpedo room. Provisions are tucked between weapons and underfloor plates. As items are consumed over the weeks, these storage spaces are progressively cleared. The volume of food consumed is itself a logistical calendar. Crew members track patrol progress partly by watching the passageways clear. Nutrition management requires deliberate planning. Fresh food, fruit, vegetables, dairy, is consumed in the first 2 weeks before it spoils. The remainder of the patrol relies on canned goods, frozen provisions, and shelf-stable items. The variety of food degrades as the patrol progresses. This degradation is a genuine morale factor. The U.S. Navy invests significantly in food quality because it is a variable that can be improved. The psychological dimension of sustained submerged operations is the factor that no engineering system can fully address. The crew lives without natural light for the entire patrol. There is no day-night cycle visible from inside the pressure hull. Artificial lighting is maintained on a schedule to support watch rotation rather than to simulate natural conditions. Circadian rhythm disruption accumulates over weeks and contributes to fatigue, mood changes, and reduced cognitive performance. The watch rotation, typically 18 hours divided into 6-hour watches, does not align with a 24-hour day. Crew members cycle through watch, off-watch, and sleep periods on a schedule that drifts relative to any natural time reference. Over 90 days, the physiological effects of this schedule, combined with confinement and separation from family, accumulate into intense stress. Operating complex systems in a high-consequence environment is a form of stress that has no direct equivalent in any other military occupation. The Virginia-class remains a marvel of engineering, but it is the endurance of the human crew that truly defines its capability. The submarine service manages these factors through a combination of selection, training, and crew culture. Selection for submarine duty includes psychological evaluation designed to identify candidates who can sustain performance in confined, isolated environments. Training exposes candidates to simulated patrol conditions before deployment. Crew culture on operational submarines develops specific practices, routines, recreational activities, informal social structures that provide psychological structure in an environment where external reference points are absent. Communications present their own constraint. A submerged submarine cannot transmit without revealing its position. It can receive very low-frequency radio transmissions through the water while submerged. VLF signals can penetrate to shallow depths, but these transmissions are one-way and carry only limited information. Full two-way communication requires the submarine to approach the surface and use an antenna, a maneuver that compromises stealth. For ballistic missile submarines whose operational value depends entirely on remaining undetected, communication is restricted to receiving essential traffic on a schedule, with no transmitted response. Crew members receive limited personal messages, family grams, brief, one-way communications from family members that are screened before transmission to exclude information that could cause acute distress. The 90-day patrol limit that governs most nuclear submarine deployments is not a technical threshold. No system aboard reaches the end of its operational life at 90 days. The reactor continues to produce power. The atmosphere systems continue to function. The weapons systems remain operational. The limit is set by the accumulation of human factors, the provision supply, the psychological endurance of the crew, and the operational assessment of crew performance after extended deployment, into a judgment that 90 days represents the boundary beyond which the return on continued deployment diminishes relative to the cost in crew welfare and performance degradation. Some patrols have extended beyond 90 days under operational necessity. The record for a submerged patrol by a nuclear submarine is held by HMS Warspite of the Royal Navy, which reportedly remained submerged for 111 days during the Cold War. The record was not set because 111 days was the operational optimum. It was set because the mission required it and the crew endured it. So why can a nuclear submarine stay underwater for months but still run out of one thing? Because the technology solved every physical constraint except one. Fuel, solved by nuclear propulsion. Oxygen, solved by electrolysis. Fresh water, solved by distillation. CO2, solved by chemical scrubbing. Propulsion, navigation, weapons, communications, all solved by decades of engineering development. The one constraint that technology cannot engineer away is the finite capacity of human beings to sustain performance in an environment that removes every reference point, light, space, connection, autonomy, that human physiology and psychology evolved to require. The submarine surfaces not when the machine needs something. It surfaces when the people do. And that distinction, in a vessel representing the most sophisticated engineering achievement in naval history, is the most important design constraint of all. If you've ever wondered what happens when a system failure does occur on a submerged nuclear submarine, how the crew responds to a reactor scram, a flooding event, or an atmosphere contamination incident hundreds of meters below the surface, with no possibility of external assistance, that response procedure, and the engineering redundancy built into every critical system to make it survivable, is something I've covered in another video.